Hey and welcome back. In the previous video we have learned how to start a call stream. But right here we want to create the agents or the RTC clients to be responsible to create the call, offer, answer, and add anything. To do that, let's go ahead and create an interface inside the WebRTC package and name it RTC clients. This is the blueprint of our class. This one will have a PeerConnection object of type PeerConnection and some functions. On destroy, you should know how to destroy these RTC clients. Offer, which will receive the target with string. Answer, and it will have the, of course, target. And on remote session received with the session description. On ICE candidate received with ICE candidates, and on local ICE candidate generated ICE candidate, and it should know who to send, so we will add the target to it. Now let's go and create the implementation of this class. We are going to name it RTC clients implementation, like this. So it's going to be a simple class with a simple constructor that will receive the connection or PeerConnection and the callback. So there's a callback that I'll write here, transfer listener of type transfer data to server callback. I guess the name says everything. Let's add JSON also. So let's add this callback here. This is going to be an interface named transfer data to server callback. And there would be only one function on transfer event to socket. It's responsible to send the generated data like session description and ICE candidates to the socket server. So it means use this function to deliver the generated packet to the other peer. Simple as that. And the data type is going to be signal message model. Let's go and actually extend from RTC client and implement the members like this. Let's move it up here. Okay, right here, the PeerConnection is going to be the PeerConnection or the connection from the constructor. Simple as that. For the undestroy, we simply want to use run catching and close the PeerConnection. That's it. Let's go and describe the offer function. We are going to use our PeerConnection and create offer. We are going to need the STP observer and media constraint. So let's go ahead and create some classes. Name my STP observer. This is going to extend STP observer from the WebRTC library. So this one has to be open class and it will implement the members. What it does, right here, we don't want to use these three callbacks. We just need on create success. So we are avoiding boilerplate here. For the observer, I simply want to use anonymous initialization and create a new instance of my class. Simple as that. And for the constraints, I'll go up here and create my constraints. Private val media constraints. So this will describe the connection every time we want to set up a call. Let's add an apply block. So we want to add some key value pair. The first one is offer to receive video, and its value is going to be true. Same goes for offer to receive audio, which means we want to say that, hey, we are going to have the video and the audio. And here, let's pass this media constraint to it. So right here, after creating offer, it means whenever on create is success, like this, we will have a description. Rename it to desk. Go back here. Whenever we created the offer, first thing that you need to do is to set it as the local description. For the observer, simply pass a new object of mySTP observer. I don't want to watch it anymore. For the description, simply pass description. And after that, it's time to use the transfer listener and give it to the WebSocket. So let's create this signal message model. The type of it is going to be signal message types.offer. Sender, of course, is us, or simple call application. User ID. Target, of course, is target, and the data is actually going to be description, just description. Simple as that. Now let's go and create the answer again. It's exactly the same, but we have to create answer. And for STP observer, we use STP observer like this and pass media constraint to it. Now let's override on create success. Let's set it as the local description. Now it's time to transfer it to the WebSocket like this. Type is going to be type answer, of course. Sender is us. Target is target. And description is the description of this session description. Pretty much straightforward. Now, on remote session received, we should use PeerConnection and set remote description to this description. Actually, we need observer here also. So we use mySTP observer initialization like this. For the iScanner received, we wanna just add it to our PeerConnection. And for the generated candidates, first we want to add it to our connection and send it to other peer. Let's use transfer listener. On transfer, create a new message model. Type of it is going to be ICE. Sender is us, of course. Target is target. And data is going to be the JSON version of the ICE candidate. Simple as that. Now that we have the RTC client's implementation, we should go inside our WebRTC factory and create this function that is in charge to generate these RTC clients. Let's see how we can do it. Let's write create RTC clients that is going to accept the RTC client's implementation. Inside the function, we will have the observer of type PeerConnection.observer. We want to have listener, and the type of it, of course, is from RTC clients.transfer callback, and it's going to return an nullable RTC clients. Simple as that. So first, let's create a PeerConnection using our PeerConnection factory inside our WebRTC factory class. If you remember, we have the PeerConnection factory that is responsible to create everything, almost everything. So let's create the connection, PeerConnection factory, create PeerConnection. We simply want to use PeerConnection .rtcconfiguration and pass the ice server to it that I'll create in a second and give it the observer. Now let's go ahead and create this ice server up here. So private val ice server is going to be a list of ice server. Right now I'll add the ice server .builder and pass this URI and then use create ice server. Simple as that. Later, if you want to have the video call, outside of your local network, you have to add turn servers here. If you don't know how to create your own turn server, I actually have some videos about it that you can create your own turn server and add it here. So let's go down here. We created the connection. Now it's time to add our local stream to the connection. So let's use connection, add stream, give it to the connection and return connection, and we check if it's not null. We want to create a simple RTC client implementation. We pass connection to it. We have the listener and the JSON. Simple as that. Now that we know how to create the RTC client, it's time actually to create it and start the call. So let's move to the next video and start the real call this time. Till the next video, see you everyone.